The diagram below shows the parts of a part of an electric circuit. A circuit junction is shown below. Well, here's what I noticed. Flowing out and flowing out, I have a total of 0.75 amps plus 0.53 amps. So I said the current out is 0.75 plus 0.53. I said I have 1.28 amps coming out. Paige, how many amps must I have coming in also? Well, I only have 0.96 coming in from the one branch, so I said the magnitude has got to be 0.32, and the direction, if you labeled it that way, I would give you a mark, or if you said down and right, I would give you 1 mark. If you said inwards, I would give it to you south of east or southeast or east of south. Sure. I didn't throw compass rose on here, so yeah. Okay, I'm going to have to rewrite this. I can tell at a glance because there's nowhere I know 2 things, and I tried doing a quick ski. Nah. What's the total resistance of this circuit? Okay, well, first of all, I'm going to have 1 over R parallel is going to be 1 over 10 plus 1 over 10. These two are in parallel with each other. I can replace R3 and R4 with, is that right, Braden? Take the reciprocal of your answer. It's not right yet. They're the same as a single 5 ohm resistor. So in my mind, I can imagine a little 5 ohm resistor here. So I get, I should write that down, 5 ohms. And our total is going to be 20 plus 5 plus 20, because now those are all in series with each other. And so I can say it's 45 ohms. If you got that, 3 out of 3. Otherwise, I would give you 1 mark if I saw that, 1 mark for finding R parallel, and 1 mark for the answer. What's the total current leaving the battery? So, I total is going to be V total over R total. They did give me the total voltage, 15. I know the total current, total resistance, 45. You get 0.3333 amps. 2 marks. Probably give you half mark for that, half mark for that, and a half mark. No, I guess 1 mark for the answer. What's the voltage drop across R1? So now I'm going to start labeling my circuit. I know that I have 0.33 amps going through here. Oh, that's enough now. I can tell you the voltage drop. V equals I times R. So it's going to be 0.3333 times 20. 6.67? Is that right? If you got that, I would give you 2 out of 2. Otherwise, if I saw that you had labeled this with a 0.33, that would get you 1 mark, and then 1 mark for the answer. Number 3, we have a terminal voltage question here. This is the EMF. This is what's printed on the side of the battery, but you're never going to get 15 volts from a battery that's actually labeled 15 volts. You're always going to lose a little bit going through the battery. How much will you lose? It depends what you hook it up to. What's the terminal voltage of the cell? The terminal voltage, I can tell you right now, my final line is going to be 15 minus I times little r. Now let's go see what I can find. I'm going to combine these. I'm going to make this 1 over R parallel equals 1 over 10 plus 1 over 10. I just did that same question. R parallel ended up being 5 ohms. So now I can say the total resistance is 5.7 ohms, because now that 5 is in series with the 0.7. The total voltage before I do anything is 15, so I can tell you the total current. It's going to be 15 divided by 5.7. This is going to be a bit of a yucky number, but such is life. And I get I'll write 2.63, but I'm going to store this on my calculator. I know the total current. This question's going to fall apart. So this is going to be 15 minus 2.63 times 0.7. 15 minus answer button times 0.7. I got a terminal voltage of 3.2 if I round off properly. I would take 3.1 depending on how you round it off, but 3.2 volts. If you got that, 4 out of 4. Otherwise, I would give you 1 mark if I saw that you would combine those. I would give you 1 mark if I saw that. I would give you 1 mark for finding total current and 1 mark for finding terminal voltage. Do you have a question, or was that okay? Oh, okay. I spoke wrong. 13.2. Suppose the bottom 10 ohm resistor is removed. The terminal voltage, well, when we remove a resistor in parallel, our total will increase. In fact, it'll increase to 10.7 ohms. And because our total just got bigger, I total just got smaller. If you really want to be fussy, it's going to be 15 divided by 10.7. 15 divided by 10.7. I did say to you, you could always just crunch the numbers as your proof. Your new current is 1.4 amps. And so, because V terminal is the EMF minus I times R, if this number got smaller, this answer will get bigger. It will increase. And if you want to be really, really fussy, it's going to be 15 minus answer button times 0.7. Instead of 13.15, it'll be 14.01. So I would give you 1 mark for increase, and then I would probably give you a half mark if I saw that, a half mark for that, and then 1 mark for your conclusion. And again, you could either do it numerically, or that's how I would do it kind of generically, intuitively. Is that okay, Danica? Yep. Number 4. Ooh, we got a terminal voltage. Ooh, I'm going to have to rewrite this because I don't see 2 things anywhere. What's the power dissipated in the 16 ohm resistor? First thing I'm going to do is I'm going to find 1 over R parallel, which is going to be 1 over 16 plus 1 over 25. R parallel is going to be 16 reciprocal plus 25 reciprocal equals reciprocal 9.7561. 9.7561. 9.7561 ohms. So I could resketch this, but I think I'm just going to say our total, I can figure it out. It's going to be 1 plus 7 plus 9.7561. It's going to be 1 plus 7 plus answer button, and I get 17.756. Have I made a mistake, or am I okay so far? Okay? So that's R total. Now I'd like to find I total. That's going to be V total, which is the EMF, divided by R total. It's going to be 15 divided by 17.756. I'm going to use my answer button. 15 divided by answer button. And I get because I'm going to be using this, I'm going to carry 5 sig figs because there's a lovely 0 there. So 0.84478. Amps. Now I'm going to go walk to my circuit and I'm going to start to label stuff. That's 0.84478 amps. That's 0.84478 amps. Do I know the amperage flowing through here? No. It's splitting up, but not evenly. If these are both 25 or both 16, I could assume it splits it evenly. And they are going to be ratios of each other, but I told you I've never bothered memorizing that trick. I think what I can start to do now is ski. Because knock, knock, I know 2 things. I know the voltage up there, 0.84478 times 7. I have 5.91346 volts. And I know the voltage loss in here. In fact, I can do it in my head because R is 1. So it's going to be, I also have 0.84478 volts. And now if I ski, I can tell you the voltage drop through there. I start with 15. I lose 5.91346. I also lose 0.84478. That leaves me in each of these with 8.24176 volts. Nope, don't write with that, Mr. Duke. 8.24176 volts. I could find I, because I know two things. I'm going to quit here, though, because I also recall power is V squared over R, and I just found V, so it's going to be that number squared over, what was the resistance? 16. You get 4.2, because this is 4.24, but there's a 5 next to it, I'd probably take 4.23 or 4.25. I'd look for 2 sig figs of accuracy. 4.25 is what it really is on mine, carrying the answer button through as much as I could. 4.25 watts. Is that correct? So if you got that, 7 out of 7, how would I give out part marks? 1 mark if I saw that somewhere. 1 mark if I saw that somewhere. 1 mark if I saw that somewhere. 1 mark if I saw that voltage, that's 4. 1 mark if I saw that voltage, that's 5. 1 mark if I saw that voltage, that's 6. And then 1 mark for the answer. That's why I said a lot of these end up being nice 7-mark questions, because you'll do 4 or 5 or 6 steps to get there. Can you give yourself a lovely score out of what, Mud?
8.
What, Owen? What's the score out of? So put a score on there